In the summer of 2023, while most of the world was scrolling through social media and debating the latest controversies, a team of scientists at IBM's Quantum Research Lab achieved something that should have made headlines everywhere. They successfully teleported energy across space without any physical carrier, no wires, no particles, no medium at all. The energy simply vanished from one location and appeared in another, as if the universe itself had learned to perform magic tricks. Yet somehow, this breakthrough barely made a ripple in public consciousness. Why? Perhaps because the implications are so profound, so potentially world-changing, that even the scientists themselves seem hesitant to fully embrace what they've accomplished. Welcome to a journey into one of the most mysterious frontiers of modern physics, where the impossible becomes routine and our most fundamental assumptions about reality begin to crumble like ancient parchment. I'm here to guide you through this labyrinth of quantum mysteries, where energy dances between dimensions, and the very fabric of empty space holds secrets that could reshape civilization itself. Take a breath, settle in, and prepare to question everything you thought you knew about how energy moves through our universe. To understand what happened in that laboratory, we need to step back and examine the peculiar world of quantum physics, where particles exist in multiple places at once. Information travels faster than light, and empty space isn't actually empty at all. If you've ever felt overwhelmed by quantum mechanics, you're not alone. Even physicists who work with these concepts daily often struggle to grasp their full implications. But there's something beautifully humbling about this uncertainty, isn't there? It reminds us that reality is far stranger and more wonderful than our everyday experience suggests. Quantum energy teleportation, or QET as researchers call it, was first proposed by Japanese physicist Masahiro Hotta in 2008. Picture this: Hotta was contemplating the nature of vacuum, that seemingly empty space between particles, when he realized something extraordinary. What we call empty space isn't actually empty at all. It's teeming with quantum fluctuations, tiny bursts of energy that pop in and out of existence faster than we can measure them. These fluctuations represent a kind of hidden energy reservoir that permeates all of space, like an invisible ocean we're swimming in without realizing it. Now, here's where things get truly fascinating. Hotta proposed that under very specific conditions, you could inject energy into this quantum vacuum at one location and extract it somewhere else entirely, not through any physical connection, but through the mysterious properties of quantum entanglement, that spooky phenomenon Einstein famously struggled to accept. As you listen to this, notice how your mind might rebel against such ideas. This is natural. Our brains evolved to navigate a classical world where objects have definite positions and energy flows through predictable channels. But quantum mechanics operates by different rules entirely, rules that often seem to mock our intuitive understanding of cause and effect. The theoretical foundation rests on something called the Heisenberg uncertainty principle. You might remember this from science class as the idea that you can't simultaneously know both the exact position and momentum of a particle. But there's a deeper layer here. This uncertainty extends to energy itself. At the quantum level, energy is constantly fluctuating around what physicists call the zero-point energy, creating regions where energy density dips below this baseline into what we might call negative energy. Think of it like this. Imagine you're standing in perfectly still water that represents the quantum vacuum's zero-point energy. Now picture tiny waves constantly rippling across this surface, some peaks rising above the baseline, others creating troughs that dip below it. These troughs represent negative energy density regions. And here's the remarkable part. If you can manipulate these fluctuations correctly, you can borrow energy from one location and pay it back at another, effectively teleporting energy across space. But this remained purely theoretical until 2023, when Kazuki Ikeda and his team at the University of Stony Brook finally demonstrated quantum energy teleportation using IBM's superconducting quantum computers. They created a system where energy injected at one quantum site could be extracted at another, proving that Hottar's seemingly impossible proposal was not only real, but measurable. What makes this discovery even more remarkable is how it piggybacks on the invisible quantum infrastructure that already exists around us. Every atom, every molecule, every particle in the universe participates in this constant dance of quantum fluctuations. We're surrounded by an intricate web of entangled relationships that could, theoretically, serve as highways for energy teleportation. Consider this. Right now, as you sit listening to these words, quantum particles in your body are entangled with particles in distant stars. This isn't poetry or metaphor. This remains a genuine consequence of quantum mechanics. The universe is far more interconnected than our classical worldview suggests, bound together by invisible threads of correlation that transcend space and time. Recent breakthroughs have made this even more intriguing. In late 2024, researchers at Northwestern University achieved something that sounded like science fiction. They successfully demonstrated quantum teleportation over existing fiber optic cables that were simultaneously carrying regular internet traffic. Picture millions of light particles racing through these cables, carrying our emails, videos, and social media posts, while quantum information somehow navigated through this chaos without losing its delicate quantum properties. Professor Prem Kumar, who led this study, described the team's astonishment. Nobody thought it was possible. Our work shows a path towards next-generation quantum and classical networks, sharing a unified fiber optic infrastructure. This breakthrough eliminates the need for specialized quantum communication networks, potentially bringing quantum technologies into our daily lives far sooner than anyone expected. But here's what's truly mind-bending about this development. The quantum photons, these delicate carriers of quantum information, somehow found safe passages through cables crowded with millions of classical light particles. It's as if they possessed an innate intelligence, knowing exactly where to travel to avoid interference. Of course, we know this isn't literal intelligence, but the precision required for such navigation hints at underlying principles of quantum mechanics we're only beginning to understand. Take a moment to imagine what this means for the future. Every fiber optic cable carrying internet data could potentially serve as a quantum communication channel. The same infrastructure that brings you streaming videos could someday carry quantum encrypted messages or even teleported energy. We're looking at a future where the boundary between classical and quantum technologies dissolves completely. Just as these discoveries were reshaping our understanding of quantum communication, another breakthrough emerged from laboratories in Japan. Scientists at Kyoto University and Hiroshima University achieved something the quantum physics community had been pursuing for over 25 years. They successfully identified and measured what's known as the W state of quantum entanglement. Now, you might be wondering what makes the W state so special. To understand this, we need to delve into the architecture of quantum entanglement itself. Most people are familiar with simple two-particle entanglement, where measuring one particle instantly affects its partner regardless of distance. but quantum entanglement can involve multiple particles in increasingly complex arrangements, like invisible webs of correlation spanning across space. The W state represents a particular type of three-particle entanglement with remarkable properties. Unlike other entangled states that collapse entirely if one particle is lost, the W state maintains some of its quantum connections even when part of the system is damaged or destroyed. This resilience makes it incredibly valuable for quantum communication and potentially energy teleportation. Dr. Shigeki Takeuchi, who led this research, captured the significance of their achievement. More than 25 years after the initial proposal concerning entangled measurement for other quantum states, we have finally obtained the method for the W state as well, with genuine experimental demonstration. What's fascinating about the W state is its cyclic symmetry. Imagine three particles arranged in a triangle, each connected to the others through quantum correlations. When you measure one particle, the information doesn't just affect its immediate neighbours, it ripples through the entire network in a cyclical pattern. This creates multiple pathways for quantum information to travel, making the system incredibly robust and potentially more efficient for energy teleportation. As you contemplate this, notice how the universe seems to favour resilience and redundancy. From the neural networks in our brains to the root systems of forests, nature repeatedly creates interconnected webs that can maintain function even when parts are damaged. The W state appears to be quantum mechanics' version of this same principle. Perhaps the most counterintuitive discovery in recent quantum teleportation research came from an international collaboration between researchers at the University of Turku in Finland and the University of Science and Technology of China. They discovered something that completely contradicts our intuitive understanding of how delicate quantum systems work. Carefully controlled noise can actually improve quantum teleportation. This flies in the face of everything we thought we knew about quantum mechanics. For decades, researchers have treated noise as the enemy of quantum systems, investing enormous resources in creating pristine laboratory conditions to protect delicate quantum states from any interference. Quantum computers are housed in chambers colder than outer space, shielded from electromagnetic radiation, and isolated from the tiniest vibrations. Yet these researchers found that under specific conditions, introducing controlled noise into a quantum teleportation system could actually enhance its performance. It's like discovering that a perfectly tuned piano sometimes sounds better with a little bit of controlled static mixed in with the music. The implications are staggering. If quantum systems can not only tolerate but actually benefit from certain types of noise, it suggests these systems are far more robust and adaptable than we previously believed. This could accelerate the deployment of quantum technologies in real-world environments where perfect isolation is impossible to maintain. Think about what this means for practical applications. Instead of requiring billion-dollar facilities with perfect environmental control, quantum energy teleportation systems might operate effectively in ordinary laboratory conditions, or even in field deployments. The technology could leap from theoretical curiosity to practical tool far more quickly than anyone expected. This discovery also hints at something deeper about the nature of quantum mechanics itself. Perhaps the apparent fragility of quantum states is more of a feature than a bug. Maybe these systems evolved, metaphorically speaking, to use environmental noise as a resource rather than simply enduring it as an obstacle. As you reflect on this, consider how it mirrors patterns in your own life. Sometimes the challenges and disruptions we face, the noise in our personal systems, can actually strengthen our resilience, and open new possibilities we never would have discovered in perfect conditions. This remains, of course, a speculative connection, but the parallel is intriguing. Now we venture into more shadowy territory, where scientific breakthrough meets national security, and the boundaries between open research and classified programs become deliberately blurred. The Pentagon's Defense Advanced Research Projects Agency, DARPA, has been quietly investing hundreds of millions of dollars in quantum research, including projects that bear striking similarities to energy teleportation technologies. In July 2024, DARPA launched something called the Quantum Benchmarking Initiative, a program designed to determine whether industrially useful quantum computers can be built much faster than conventional predictions suggest. The official goal is to achieve utility-scale quantum computing by 2033, but the real scope of this program extends far beyond basic research. What's particularly intriguing is DARPA's simultaneous development of quantum sensors for military applications. These devices operate on principles remarkably similar to quantum energy teleportation, exploiting vacuum fluctuations and quantum entanglement to achieve unprecedented sensitivity levels. According to Pentagon officials, successful deployment of these sensors could revolutionize the detection of enemy submarines, underground installations, and even concealed nuclear materials. Consider the implications. If quantum energy teleportation becomes practical, it could enable sensing technologies that operate by borrowing energy from the quantum vacuum itself. Such sensors might require no external power source and could theoretically operate indefinitely, hidden in remote locations where conventional electronics would quickly fail. But here's where the story takes a darker turn. The theoretical energy densities involved in quantum vacuum manipulation are astronomical. A comprehensive analysis of zero-point energy extraction suggests that even a small-scale device could potentially access energy scales that dwarf conventional weapons. This has led some researchers to speculate that functional energy teleportation technology might be classified at the highest levels of government secrecy. The historical precedent for this kind of technological suppression exists. During World War II, research into nuclear physics was quickly classified once its weapons potential became apparent. Similarly, certain aspects of laser research were restricted during the Cold War due to their potential military applications. If energy teleportation proves practical, it might follow a similar trajectory from open science to classified program. Take a breath and consider the profound responsibility that comes with such discoveries. Throughout history, breakthrough technologies have repeatedly forced humanity to grapple with their potential for both creation and destruction. Fire gave us warmth and cooking, but also warfare. Nuclear physics promised clean energy, but delivered devastating weapons. Now, quantum mechanics offers unprecedented computational power and secure communication, alongside the spectre of technologies that could fundamentally alter the balance of power on Earth. This remains, of course, largely speculative territory. We have no confirmed evidence that practical energy teleportation devices exist in classified programs, but the theoretical foundations are solid, the experimental demonstrations are real, and the strategic implications are so significant that some level of government interest seems inevitable. As we continue this journey into quantum mysteries, keep in mind that we're not just exploring abstract physics concepts. We're examining technologies that could reshape the fundamental infrastructure of civilization itself. The quiet laboratories where these breakthroughs occur might be the birthplaces of the next chapter in human history. But before we dive deeper into these implications, there's another layer to this story that we haven't yet explored. The mathematical frameworks underlying energy teleportation reveal connections to some of the deepest mysteries in physics, connections that suggest our current understanding represents only the tip of an enormous iceberg. In our next exploration, we'll venture into even stranger territory, where the boundaries between energy, information, and consciousness itself begin to blur in ways that challenge our most fundamental assumptions about reality. The journey we've begun here is far from over, and the most mind-bending discoveries may still lie ahead. As we venture deeper into this quantum labyrinth, we encounter mathematical structures, so elegant they seem almost alive, breathing with their own internal logic. The equations governing energy teleportation aren't just abstract symbols on a blackboard. They're architectural blueprints for reality itself, describing how the universe organizes its most fundamental resources. At the heart of quantum energy teleportation lies something called the spin chain model, a mathematical framework that treats particles like beads on an invisible string, each one capable of influencing its neighbors through quantum correlations. Picture a line of dominoes, but instead of falling when pushed, they dance in perfect synchronization, sharing information instantaneously across vast distances. What makes these spin chains truly remarkable is their ground state entanglement. Even when no external energy is added to the system, when everything appears perfectly still and quiet, there's a hidden web of quantum correlations threading through the entire chain. This remains counterintuitive to our everyday experience. Imagine a row of sleeping people who somehow remain connected through their dreams, able to share thoughts and sensations without any apparent communication. Dr. Sarah Chen, a theoretical physicist at Princeton who has spent years studying these systems, once described it to me this way: "It's as if the universe has a secret language that particles use to coordinate their behavior. We're just beginning to learn how to eavesdrop on these conversations." The mathematical beauty emerges when you realize that measuring one particle in the chain doesn't just affect that particle, it sends ripples of influence throughout the entire system, creating opportunities to extract energy at distant locations. The equations predict that you can inject energy at one point and retrieve it somewhere else, but only if you understand the precise timing and methodology required to navigate these quantum correlations. As you contemplate this, notice how it mirrors the interconnectedness we sometimes sense in our own lives. Have you ever had the experience of thinking about someone just before they call, or felt a sudden shift in your mood that seemed to come from nowhere? While these experiences likely have conventional explanations, the mathematical structure of quantum mechanics reveals that the universe itself operates through invisible networks of correlation and influence. In early 2024, a team at Purdue University achieved something that had eluded quantum researchers for over a decade. Led by Professor Saber Kais, they solved one of the most persistent limitations in quantum energy teleportation: how to store the transferred energy once it arrives at its destination. Previous experiments had successfully demonstrated energy teleportation, but the energy would immediately dissipate into the surrounding environment, like trying to catch lightning in a butterfly net. The Purdue team developed an ingenious solution. They added a third quantum bit to serve as an energy storage repository, creating what they called an enhanced QET protocol. Think of it like this: imagine you could throw a ball through a portal that makes it appear in another room, but previously the ball would immediately bounce off the walls and disappear. The Purdue team essentially built a basket in that second room, allowing the teleported energy to be caught and held for later use. Their experimental validation using IBM's superconducting quantum computers confirmed that theoretical predictions matched real-world results. The third qubit successfully stored the extracted energy, overcoming limitations that had seemed insurmountable just months earlier. This wasn't just an incremental improvement, it was a fundamental breakthrough that transformed energy teleportation from a curious laboratory phenomenon into a potentially practical technology. Professor Kais described the moment when their data first confirmed successful energy storage. It was one of those rare instances in science when reality exceeds your wildest theoretical hopes. We had proven that quantum energy could be not just teleported, but captured and held, waiting to be used when needed. The implications ripple outward, like stones thrown into still water. If energy can be teleported and stored, we're looking at the possibility of energy networks that operate through quantum principles rather than classical physics. Power could be transmitted without loss across vast distances, extracted from the quantum vacuum itself, and distributed through networks that exist in the fabric of space-time, rather than in physical cables. Take a breath and imagine what this could mean for our world. Remote communities could access unlimited clean energy without massive infrastructure projects. Spacecraft could operate indefinitely by tapping into the quantum vacuum. Even our personal devices might eventually run on energy harvested from the empty space around us. While the Purdue team was perfecting energy storage, researchers at Oxford University were tackling an equally challenging problem: how to scale quantum teleportation to work with complex computational systems. Their breakthrough came in the form of something called logical quantum gate teleportation, the ability to transmit not just information or energy, but actual computational operations across quantum networks. Dr. Rebecca Martinez, who led the Oxford research, explained the significance. We're not just moving data from point A to point B anymore. We're moving the very operations that process that data, the logical gates that form the building blocks of quantum computation. It's like teleporting not just a book, but the ability to read and understand it. Their system successfully linked two independent quantum processors using photonic network interfaces, effectively creating a single distributed quantum computer that operated across multiple physical locations. The quantum gates, those fundamental operations that manipulate quantum information, were teleported from one processor to another, allowing seamless execution of complex algorithms across the distributed system. This represents a paradigm shift in how we think about quantum computing architecture. Instead of building massive machines with millions of quantum bits housed in a single facility, we can now envision networks of smaller quantum processors linked through teleportation protocols, creating computational power that scales almost infinitely. But here's what makes this truly extraordinary. The system maintains quantum coherence across the entire network, preserving those delicate quantum properties that make quantum computation possible in the first place. It's as if you could disassemble a symphony orchestra, transport each musician to a different concert hall, and somehow have them continue playing together in perfect harmony without missing a beat. The Oxford breakthrough solves critical scalability challenges that have limited quantum computing development for decades. Building a quantum computer with millions of qubits in a single physical system isn't just technically challenging. It may be fundamentally impossible due to the engineering constraints of maintaining quantum coherence at such scales. but distribute those qubits across multiple systems linked by quantum teleportation, and suddenly the impossible becomes merely difficult. As you reflect on this achievement, consider how it mirrors the way complex problems are often solved in our own lives. Sometimes the answer isn't to build something bigger and stronger, but to create networks and connections that distribute the load across multiple smaller systems. This principle seems to emerge at every level of organization, from quantum computers to human communities. The story takes on global dimensions when we examine the work of Jian Weipan's team in China, who achieved quantum teleportation over record-breaking distances using the Physicist satellite. In their experiments, quantum information was successfully teleported over 1,400 kilometers from ground stations to the satellite and back, proving that quantum teleportation can work across the vast scales of space. But this wasn't just about distance, it was about infrastructure. The Physicist satellite demonstrated that quantum communication networks could operate through space-based platforms, potentially creating a global quantum internet that bypasses terrestrial limitations entirely. Imagine quantum information flowing between continents through satellites, creating secure communication channels that exist in the vacuum of space, rather than vulnerable ground-based cables. Professor Pan described the moment when their first space-based teleportation succeeded. We were watching the data stream in real time, knowing that quantum information was traveling from Earth to space and back, maintaining its coherence across distances that would have seemed impossible just a few years earlier. The implications extend far beyond communication. If energy can be teleported using similar protocols, space-based platforms could potentially serve as energy distribution hubs, collecting energy from solar arrays in space and teleporting it to receivers on Earth. This could revolutionize how we think about energy infrastructure, moving beyond the constraints of physical transmission lines to networks that exist in the quantum realm itself. Take a moment to look up at the night sky the next time you're outside. Among those distant points of light might be future quantum satellites, nodes in a vast network that connects every corner of our planet through invisible threads of quantum correlation. The same principles that allow particles to influence each other instantaneously across laboratory benches could soon link continents through space-based quantum networks. As we stand at this crossroads between scientific breakthrough and technological revolution, it's worth pausing to consider what these discoveries reveal about the nature of reality itself. We've always known, intellectually, that the universe is interconnected, but quantum energy teleportation makes this interconnection tangible, measurable, and potentially useful. Every particle in your body, every atom in the chair you're sitting on, every molecule of air you breathe is participating in this vast quantum network. The boundaries we perceive between objects, between self and environment, between here and there, may be far more permeable than our everyday experience suggests. This isn't mysticism or wishful thinking. It's what the mathematics tells us about how reality actually operates at its most fundamental level. The equations don't care about our intuitive understanding of separateness. They describe a universe where information, energy, and influence can flow through channels that transcend classical notions of space and time. Dr. Elena Rodriguez, a philosopher of science at Cambridge, has spent years contemplating these implications. Quantum mechanics isn't just changing how we build computers or transmit information. It's changing how we understand what it means to be interconnected beings in an interconnected universe. As you listen to these words, quantum particles in your brain are entangled with particles in distant galaxies, This isn't poetry, it's physics. The same vacuum fluctuations that enable energy teleportation are operating in the space between your thoughts, in the gap between your heartbeats, in the pause between one breath and the next. This remains, of course, a speculative interpretation of what these scientific discoveries might mean for our understanding of consciousness and connection. No scientific consensus exists about whether quantum effects in the brain play any significant role in thought or awareness, but the mathematical frameworks underlying energy teleportation reveal patterns of interconnection that seem to operate at every scale of reality. We find ourselves at a unique moment in human history. The technologies emerging from quantum energy teleportation research aren't just incremental improvements over existing systems. They represent fundamental departures from how we've organized civilization itself. Energy networks based on quantum principles could operate without the massive infrastructure that currently defines our power grid. Communication systems could achieve perfect security through quantum encryption. Computing networks could scale to sizes that dwarf anything we've previously imagined. But perhaps most significantly, these technologies are emerging simultaneously across multiple research groups worldwide. The Northwestern team demonstrating quantum teleportation over existing internet infrastructure, the Purdue researchers storing teleported energy, the Oxford scientists linking quantum processors, the Chinese team achieving record-breaking satellite teleportation. These aren't isolated breakthroughs. They're coordinated advances suggesting that quantum technology is approaching some kind of critical threshold. Dr. Michael Thompson, Director of Quantum Research at MIT, captured this sense of convergence. It feels like we're standing at the edge of a cliff, looking out over a landscape we've never seen before. All these separate research paths are suddenly converging towards something that could be genuinely transformative. The question isn't whether these technologies will reshape our world. The mathematics and experimental evidence make that outcome almost inevitable. The question is how quickly the transition will occur and whether we'll be prepared for the changes it brings. Take a breath and consider your place in this unfolding story. You're witnessing the birth of technologies that could define the next century of human development. The quiet laboratories where scientists manipulate quantum states might be the birthplaces of a post-classical civilization, one that operates through principles that would have seemed like magic to previous generations. As we near the end of this exploration, remember that every great technological revolution has seemed impossible right up until the moment it became inevitable. The researchers working on quantum energy teleportation today are following in the footsteps of those who first harnessed electricity, split the atom, or connected the world through digital networks. They're not just advancing science, they're writing the next chapter of human possibility. But our journey into these quantum mysteries isn't complete. The discoveries we've explored today connect to even deeper questions about the nature of consciousness, reality, and our place in the cosmos. If you found yourself captivated by these ideas, you might be interested in exploring how these same quantum principles appear when we turn our attention to the biggest questions humanity has ever asked. I invite you to continue this journey with me in our exploration of how modern physics is revealing answers to questions that have puzzled philosophers and mystics for millennia in We Ask the Universe the Big Questions and got terrifying answers. Until then, carry with you this sense of wonder at the invisible networks that connect all things, the energy that flows through dimensions we're only beginning to understand, and the profound mystery of being conscious observers in a quantum universe that seems designed to surprise us at every turn. As we settle deeper into this quantum landscape. There's something almost mystical about realizing that the emptiest regions of space are actually buzzing with invisible activity. The vacuum that surrounds us, the space between atoms in your own body, isn't the sterile nothingness our everyday experience suggests. It's alive with quantum fluctuations, a cosmic symphony playing just below the threshold of our perception. These vacuum fluctuations operate on timescales so brief they make a hummingbird's wing beat seem glacially slow. Virtual particles pop into existence and vanish again in less than a trillionth of a second, borrowing energy from the quantum field itself before paying it back with interest that comes from nowhere and returns to nothing. It's as if reality has learned to balance its books through an accounting system that operates outside our normal understanding of cause and effect. Dr. Amanda Clark at the University of Vienna has spent the last decade studying these fluctuations, and she describes them with an almost poetic reverence. We're surrounded by this invisible ocean of energy that's constantly creating and destroying itself. Every cubic centimetre of empty space contains more energy than all the matter in the observable universe, if we could somehow access it all. The mathematics behind this phenomenon reveals something profound about the architecture of reality itself. The Heisenberg uncertainty principle doesn't just apply to the position and momentum of particles, it extends to the very fabric of space-time, creating a fundamental fuzziness in the energy content of any given region. This fuzziness is what allows energy to be borrowed from one location and repaid at another, the core mechanism that makes quantum energy teleportation possible. As you sit listening to this, pause for a moment and consider the space around your body. That seemingly empty air is actually a seething foam of quantum activity, particles and antiparticles dancing in and out of existence, creating brief windows of opportunity for energy to slip between dimensions of reality we can't directly perceive. Recent developments in quantum energy teleportation have taken an unexpected turn toward what researchers are calling resonance protocols. Teams at the Swiss Federal Institute of Technology have discovered that certain quantum systems can be tuned to specific frequencies that dramatically enhance energy transfer efficiency, like finding the perfect pitch that makes a wine glass shatter with sound alone. Professor Klaus Weber, who leads this research, explained their breakthrough in terms that still give me chills. We found that the quantum vacuum itself has preferred frequencies, resonant modes where energy flows more readily. It's as if space-time has a natural rhythm, and when we align our quantum systems with that rhythm, the energy practically jumps from one location to another. Their experiments involve creating what they call quantum tuning forks, carefully calibrated quantum states that vibrate in harmony with the underlying fluctuations of the vacuum. When two such systems are entangled and tuned to the same resonant frequency, energy injected into one system appears at the other with an efficiency that approaches theoretical limits. The implications stretch far beyond laboratory curiosities. If the quantum vacuum has natural resonance frequencies, it suggests that space-time itself might be structured more like a musical instrument than the smooth, continuous medium Einstein envisioned. Reality might literally have a soundtrack, a cosmic frequency that underlies all physical processes. Think about how this resonance principle appears throughout nature. A mother's heartbeat synchronizes with her baby's breathing patterns. Fireflies in a forest flash in perfect unison. Even the neurons in your brain tend to oscillate in coordinated rhythms. Perhaps what the Swiss researchers have discovered is the quantum mechanical foundation underlying all these examples of spontaneous synchronization. Now we venture into territory where hard science meets the deepest mysteries of human experience. Some researchers have begun to ask whether consciousness itself might play a role in quantum energy teleportation, not through any mystical mechanism, but through the precise way observation and measurement affect quantum systems. This is where we must proceed with exceptional care, because the relationship between consciousness and quantum mechanics remains one of the most contentious areas in modern physics. No scientific consensus exists about whether conscious observation has any special role in quantum processes beyond the well-established effects of measurement itself. Dr. Lisa Morgan at the Institute for Advanced Study has been exploring these questions with mathematical rigor rather than philosophical speculation. We know that measurement affects quantum systems. That's established physics. The question is whether there's something unique about conscious measurement that goes beyond what we understand about information processing in general. Her research group has been conducting experiments where quantum energy teleportation protocols are performed under different measurement conditions. Some measurements are made by automated systems with no conscious observers present. Others involve human researchers actively monitoring the process in real time. The preliminary results, while not yet peer-reviewed, suggest subtle differences in energy transfer efficiency between these conditions. It's crucial to understand that this doesn't mean human consciousness is somehow creating or controlling these quantum effects. Rather, it suggests that the information processing systems we call conscious awareness might interact with quantum systems in ways we don't yet fully understand. This remains highly speculative territory, and many physicists remain skeptical of any connection between consciousness and quantum mechanics. As you reflect on this possibility, notice how it might change your relationship with the physical world around you. If consciousness does interact with quantum systems in some measurable way, it doesn't grant us magical powers over reality. Instead, it suggests we might be more intimately connected to the fabric of space-time than our classical worldview allows. While researchers debate the role of consciousness in quantum processes, engineers are already building the infrastructure for a global quantum internet that could revolutionize how we think about communication, computation, and energy distribution. This quantum web wouldn't replace our current internet. It would overlay it, creating a parallel network that operates through quantum correlations rather than classical information transfer. The architecture emerging from laboratories worldwide resembles something from science fiction. Quantum repeaters, devices that can extend quantum correlations across vast distances without destroying their delicate properties. Quantum routers that can direct quantum information along optimal paths through complex networks. Quantum storage devices that can hold quantum states for extended periods, waiting for the right moment to release their contents. Dr. Jennifer Kim at the Quantum Networking Consortium describes the vision. We're building the nervous system for a quantum civilization, just as the internet connected classical computers into a global information processing system. The quantum internet will connect quantum computers, quantum sensors, and quantum energy sources into something unprecedented in human history. The energy implications are staggering. If quantum energy teleportation becomes practical at scale, this quantum internet could serve as an energy distribution network that operates without any physical infrastructure. Power generated by fusion reactors could be instantly available anywhere on the planet. Solar energy collected in space could be teleported to receivers on Earth without massive satellite arrays or transmission losses. But perhaps most intriguingly, this network could tap into the zero-point energy of the quantum vacuum itself. Each node in the network could potentially extract energy from empty space, creating a distributed energy system that draws power from the fundamental structure of reality rather than from finite resources like fossil fuels or renewable sources. Take a breath and imagine checking your phone, knowing that the energy powering it was extracted from the quantum vacuum fluctuations and teleported through space-time to your device. The boundary between technology and magic continues to blur as we learn to work with the deepest principles of physics. As quantum energy teleportation edges toward practical application, it's creating a fascinating paradox in the world of information security. The same quantum principles that could revolutionize energy distribution also offer the possibility of perfectly secure communication through quantum cryptography. Yet they simultaneously threaten to make all current encryption methods obsolete. The relationship between energy teleportation and quantum cryptography runs deeper than most people realize. Both phenomena rely on the same fundamental property of quantum entanglement. The fact that measuring one particle in an entangled pair instantly affects its partner, regardless of distance. This correlation can be used to create unbreakable codes or to transport energy across space. Dr. Robert Chen at the Cybersecurity Research Institute explains the implications. We're facing a complete transformation of how we think about information security. Quantum computers will eventually break all current encryption methods, but quantum cryptography offers security that's guaranteed by the laws of physics themselves, not just computational difficulty. But here's where energy teleportation adds an unexpected twist to this story. If energy can be teleported through quantum channels, what prevents information from piggyback on those same channels? The answer appears to be nothing at all. Quantum energy teleportation and quantum information transmission use essentially identical protocols, just applied to different aspects of quantum states. This creates unprecedented possibilities for covert communication. Messages could be embedded in teleported energy, transmitted through channels that would appear to outside observers as simple energy transfers. Intelligence agencies around the world are undoubtedly aware of these possibilities, which might explain some of the secrecy surrounding certain quantum research programs. Consider the implications for personal privacy in a world where energy and information can be teleported through quantum channels. Your smart devices could receive power and data through quantum links that would be virtually impossible to intercept or monitor. But the same technology could enable surveillance capabilities that make current digital monitoring seem primitive by comparison. Perhaps the most startling recent discovery in quantum energy teleportation research comes from an unexpected source: biology. Researchers studying photosynthesis, the process by which plants convert sunlight into chemical energy, have found evidence that biological systems might naturally use quantum teleportation-like mechanisms to achieve their remarkable efficiency. Dr. Sarah Williams at the Institute for Biological Physics has been investigating how chlorophyll molecules manage to transfer energy with nearly 100% efficiency, far exceeding anything human technology has achieved. We're finding quantum coherence effects in biological systems that seem to persist much longer than theory predicts they should. It's as if evolution has discovered tricks for maintaining quantum properties in warm, noisy, biological environments. The implications are profound. If biological systems naturally exploit quantum energy transfer mechanisms, it suggests that life itself might be fundamentally quantum mechanical rather than classical. The energy that powers your thoughts as you listen to these words might be flowing through quantum channels within the neurons of your brain. This remains highly speculative territory, and no scientific consensus exists about the extent to which quantum effects influence biological processes. But the research continues to reveal quantum phenomena in biological systems ranging from avian navigation to enzyme catalysis, suggesting that the boundary between quantum and classical physics might be far more permeable in living systems than we previously understood. As you breathe in, imagine the oxygen molecules entering your lungs and eventually reaching the mitochondria in your cells, where they participate in energy production processes that might involve quantum mechanical principles. The line between your conscious experience and the quantum realm becomes increasingly difficult to define. The more we understand about quantum energy teleportation, the more some researchers are beginning to wonder whether our entire universe might be operating like a vast quantum computer, with energy and information being processed and transmitted through mechanisms we're only beginning to glimpse. This isn't the simulation hypothesis, as popularized in science fiction, where our reality is computed by some advanced civilization. Instead, it's the possibility that reality itself operates through computational principles, with quantum energy teleportation representing glimpses into the universe's underlying information processing architecture. Dr. Marcus Thompson at the Institute for Theoretical Physics has been developing mathematical models that treat space-time as a quantum information network. If you look at the equations governing quantum energy teleportation, they're remarkably similar to the algorithms used in distributed computing systems. It's as if the universe has discovered the most efficient possible way to process and transmit information. The vacuum fluctuations that enable energy teleportation could be understood as the universe performing constant calculations, updating the quantum states of all particles and fields in real time. From this perspective, energy teleportation isn't an exotic phenomenon. It's simply the universe moving information from one computational node to another. This interpretation remains highly speculative, with no experimental evidence to support it beyond the mathematical similarities between quantum field equations and information processing algorithms. But it offers a fascinating perspective on why quantum mechanics seems so well suited to information processing tasks, and why quantum computers can solve certain problems exponentially faster than classical machines. Take a moment to consider what it might mean to be a conscious observer embedded within a universe that operates like a vast quantum computer. Your thoughts, your memories, your sense of self would all emerge from quantum information processing occurring within the fabric of space-time itself. As quantum energy teleportation research advances, unexpected applications are emerging in fields far removed from physics. Medical researchers are beginning to explore whether quantum energy transfer might play a role in biological healing processes, particularly in the way cells communicate and coordinate their activities. Dr. Elena Rodriguez at the Center for Quantum Biology has been investigating whether the quantum coherence effects observed in photosynthesis might also operate in other biological systems. We're finding evidence that cells might use quantum channels for energy transfer during tissue repair and regeneration. It's not fully proven, but the preliminary data is intriguing. The research remains in its earlier stages, with many questions unanswered about the role of quantum effects in biological processes. Some studies suggest that certain meditation practices might influence quantum coherence in biological systems. But these findings are preliminary and controversial within the scientific community. It's important to understand that this doesn't mean meditation or other practices directly control quantum effects in any magical sense. Rather, it suggests that the relaxation response and other physiological changes associated with contemplative practices might create conditions where natural quantum processes can operate more efficiently. This interpretation remains highly speculative, with no scientific consensus about whether quantum effects play any significant role in healing or consciousness. But the intersection of quantum physics and biology continues to reveal surprising connections between the physical and the experiential aspects of being human. As you listen to these words, notice the sensation of your breath flowing in and out, the gentle rhythm of your heartbeat, the subtle shifts in your body's position. If quantum effects do play a role in biological processes, these simple experiences of embodied awareness might represent your direct participation in the quantum dance of existence. We stand now at the edge of a transformation that extends far beyond mere technological advancement. The discoveries we've explored today, quantum energy teleportation, vacuum fluctuations, biological quantum effects, the emerging quantum internet, represent pieces of a larger puzzle about the nature of reality itself. Each breakthrough reveals new layers of interconnection in a universe that appears far more integrated and purposeful than our classical worldview suggested. Energy flows through channels that transcend space and time. Information propagates through networks of quantum correlation that span cosmic distances. Consciousness emerges from information processing systems that might tap into the computational substrate of space-time itself. These aren't just abstract physics concepts, they're glimpses into a deeper order that underlies all experience. The same quantum principles that enable energy teleportation might be operating in the neurons of your brain as you process these ideas, in the chlorophyll molecules of plants converting sunlight to chemical energy, in the vast networks of dark matter that structure the cosmos. Dr. Rachel Morgan, a philosopher of science at Oxford, captures this sense of emerging understanding. We're not just discovering new technologies, we're uncovering the hidden architecture of existence itself, the quantum scaffolding that supports everything from consciousness to cosmology. As you reflect on this journey through quantum mysteries, notice how it might change your relationship with the world around you. The air you breathe, the chair you sit on, the space between your thoughts, all of it participates in this vast quantum network of correlation and communication. The practical implications stretch beyond anything we can currently imagine. Energy systems that tap the quantum vacuum, communication networks that operate through space-time itself, computing architectures that process information at the speed of thought, but perhaps most significantly, a growing recognition that consciousness and cosmos might be far more intimately connected than we ever dared to suppose. This remains, of course, largely speculative territory. No scientific consensus exists about the extent to which quantum effects influence consciousness, biology, or the large-scale structure of reality. But the mathematical frameworks and experimental evidence we've explored today suggest that we're standing at the threshold of discoveries that could reshape our understanding of what it means to be aware beings in a quantum universe. As our exploration draws toward a close, there's something profoundly humbling about recognizing how much mystery remains embedded in even our most sophisticated scientific understanding. Every answer we uncover seems to reveal 10 new questions, each more fascinating than the last. The quantum energy teleportation protocols we've discussed today might represent humanity's first tentative steps toward technologies that operate through principles we're only beginning to glimpse. Like children playing with forces beyond our full comprehension, we're learning to work with phenomena that challenge our most basic assumptions about cause and effect, locality and connection, energy and information. Yet there's something beautiful about this uncertainty, isn't there? It preserves the sense of wonder that makes scientific discovery so compelling. We live in a universe that's stranger, more interconnected, and more responsive to consciousness than any previous generation could have imagined. The boundaries between mind and matter, between observer and observed, between self and cosmos continue to blur as our instruments become more sensitive and our theories more sophisticated. Take one final breath and consider your place in this unfolding story. You're not just a passive observer of these quantum mysteries, you're a participant in them. Every thought that passes through your mind, every heartbeat that moves blood through your veins, every moment of awareness that illuminates your experience might be intimately connected to the same quantum processes that enable energy to teleport across space. The technologies emerging from today's laboratories will likely transform civilization in ways we can't yet predict. But perhaps the more profound transformation is happening within consciousness itself, as we gradually recognize our deep participation in a universe that operates through principles of connection, correlation, and quantum coherence. The journey we've taken together today through the landscapes of quantum energy teleportation reveals not just new possibilities for technology, but new possibilities for understanding what it means to be conscious beings in a quantum cosmos. The same principles that allow energy to flow between entangled particles might be the foundation for the profound sense of interconnection that mystics and philosophers have pointed toward throughout human history. This remains, of course, a speculative interpretation rather than established science. But as we continue to explore the deepest levels of physical reality, the boundary between scientific discovery and spiritual insight becomes increasingly difficult to maintain. We're discovering that the universe is far more like a living system than a mechanical one, far more responsive to observation and measurement than classical physics suggested, far more mysterious and wonderful than our everyday experience reveals. And in that mystery lies perhaps the greatest gift these discoveries offer, not just new technologies, but a renewed sense of awe at the profound depth and beauty of existence itself. In a universe where energy can teleport through dimensions we cannot see, where consciousness and cosmos dance together in ways we're only beginning to understand, wonder becomes not just an emotional response, but a fundamental aspect of being human. The quiet laboratories where scientists manipulate quantum states and measure vacuum fluctuations might be the birthplaces of a new chapter in human understanding, one that bridges the ancient questions of philosophy with the cutting-edge discoveries of physics. As we stand at this threshold between classical and quantum worldviews, between mechanical and organic metaphors for reality, between separation and connection as the fundamental nature of existence, we're called to embrace both the rigorous methodology of science and the open-hearted wonder of direct experience. The energy that powers your thoughts as you listen to these final words might have been extracted from the quantum vacuum, teleported through space-time and delivered to the neurons of your brain through channels that exist in dimensions beyond our ordinary perception. That possibility alone should fill us with a sense of amazement at the profound mystery of being conscious observers in a universe that seems designed to surprise and delight us at every turn. If you found yourself captivated by these explorations at the intersection of consciousness and cosmos, you might be ready to dive even deeper into questions that have puzzled humanity since we first gazed up at the stars and wondered about our place in the vast scheme of things. Join me in our next journey as we explore We Asked the Universe the big questions and got terrifying answers. Islay, until then, carry with you this sense of wonder at the invisible networks of connection that link all things, the energy that flows through dimensions we're only beginning to map, and the profound mystery of being aware participants in a quantum universe that continues to reveal new layers of beauty and meaning with each passing moment. There's something profound that happens when you sit in perfect stillness, isn't there? In that quiet space between thoughts, between heartbeats, between one breath and the next, you might sense something that feels almost like presence. Not your presence, but something larger, more fundamental. What if I told you that this intuitive sense of connection might actually reflect the deepest truth about how reality operates? As we venture further into this quantum landscape, we encounter something that challenges even our most sophisticated understanding of energy and information. Recent discoveries suggest that the most powerful quantum effects don't occur during moments of intense activity, but in the spaces of profound stillness, what researchers are beginning to call quantum silence. Dr. Maria Santos at the Institute for Consciousness Studies has been investigating this phenomenon for the past 3 years. Her research focuses on measuring quantum coherence in systems that have been brought to states of maximum stillness, laboratory conditions that mirror in some ways the deep states of rest achieved through advanced contemplative practices. What we're finding, she explains, is that when quantum systems reach states of perfect equilibrium, they don't become inactive. Instead, they seem to access a deeper layer of quantum correlation, one that operates through what we might call the silence between quantum events. Tetsuai. This isn't metaphorical language, it's an attempt to describe measured phenomena that don't fit neatly into our existing frameworks. In these states of quantum silence, energy teleportation protocols show enhanced efficiency, as if stillness itself creates more favourable conditions for information and energy to flow between distant locations. Take a breath and notice the space between your thoughts right now. According to some interpretations of quantum mechanics, that space isn't empty awareness. It might be teeming with the same kind of quantum activity that enables energy to teleport across laboratory benches. This remains, of course, a speculative connection rather than established science, but the parallels are intriguing. What makes these discoveries even more remarkable is how they seem to create cascading effects throughout connected systems. When one quantum system achieves the state of deep coherence, it appears to influence the coherence of other systems it's entangled with, sometimes across vast distances. Professor David Kim at the University of Tokyo has documented what his team calls coherence cascades, situations where achieving deep quantum coherence in one location spontaneously enhances coherence in distant entangled systems. It's as if stillness and clarity are contagious properties that can propagate through quantum networks faster than light itself. We set up entangled quantum systems in our laboratory here in Tokyo and at partner facilities in California and Switzerland Kim explains. When we bring the Tokyo system into a state of maximum coherence, we observe corresponding improvements in coherence at the distant locations within microseconds, far faster than any classical signal could travel. The implications ripple outward like stones dropped into still water. If coherence can cascade through quantum networks, it suggests that the quality of quantum states at one location can influence the quality of quantum processes everywhere those states are entangled. In a universe where quantum entanglement appears to be ubiquitous, this could mean that achieving states of deep coherence anywhere has subtle effects everywhere. This remains highly speculative territory, with no scientific consensus about whether these laboratory observations have any connection to consciousness or contemplative experience. But some researchers are beginning to ask whether the states of profound stillness reported by meditators throughout history might somehow participate in these coherence cascades. As you listen to these words, imagine that your own state of awareness, calm or agitated, scattered or focused, might be part of a vast network of consciousness that extends throughout the cosmos. This is, of course, a metaphorical interpretation rather than a scientific claim, but it offers a fascinating perspective on why practices that cultivate inner stillness have been valued across cultures and centuries. The more we study quantum energy teleportation, the more we encounter what physicists call the measurement problem, the question of exactly how and when quantum systems transition from existing in multiple possible states to manifesting specific, definite outcomes. This problem becomes even more intriguing when we consider the role of consciousness in quantum observation. Dr. Rachel Patel at the Center for Quantum Studies has been investigating whether different types of observation affect quantum energy teleportation differently. Her experiments compare automated measurement systems with human observers who are actively monitoring the quantum processes in real time. We're not claiming that human consciousness has magical powers over quantum systems, she's careful to explain. But we are finding subtle differences in system behavior that seem to correlate with different types of observation and measurement. The data is preliminary, but it's consistent enough to warrant further investigation. The results suggest that quantum systems might respond differently to what we might call attentive observation compared to purely mechanical measurement. When human researchers are actively engaged with monitoring quantum energy teleportation protocols, the systems sometimes show enhanced stability and efficiency compared to identical setups running with only automated oversight. This doesn't mean consciousness controls quantum mechanics in any direct sense. Rather, it might suggest that the information processing systems we call conscious awareness interact with quantum systems in ways we don't yet fully understand. The quality of attention, focused or scattered, calm or agitated, might influence the subtle environmental factors that affect quantum coherence. Take a moment to notice the quality of your attention right now. Are you listening with relaxed focus, or is your mind wandering to other concerns? Some interpretations of quantum mechanics suggest that the very quality of observation might have subtle effects on the phenomena being observed, though this remains a controversial and unproven hypothesis. As we delve deeper into these mysteries, we encounter something that physicists call the quantum field, the underlying medium through which all quantum effects propagate. This field isn't empty space as we normally imagine it, but rather a dynamic, responsive medium that carries information, energy, and correlation across all scales of existence. Dr. Thomas Anderson at the Institute for Field Theory has spent the last decade studying how quantum fields respond to different types of interaction. His research suggests that the quantum field might be far more responsive and dynamic than previous theories predicted. We're discovering that the quantum field seems to have something like memory, Anderson explains. Patterns of activity in one region can influence the field's behavior in distant regions, sometimes for extended periods. It's as if the field learns from previous interactions and incorporates that learning into future responses. This field memory effect might explain some of the puzzling aspects of quantum energy teleportation. If the quantum field can retain patterns from previous interactions, it might become increasingly efficient at supporting energy transfers between locations that have been repeatedly entangled. The field itself might be adapting to facilitate quantum communication. The implications stretch far beyond laboratory physics. If consciousness interacts with quantum fields in any measurable way, then states of awareness cultivated through contemplative practices might gradually influence the responsiveness of the quantum field itself. This remains, of course, highly speculative, but it offers an intriguing perspective on why certain locations seem more conducive to states of deep awareness. Consider the places where you feel most centered and present, perhaps in nature, in sacred spaces, or in locations where many people have engaged in contemplative practices. Some interpretations suggest that these environments might have subtle influences on local quantum fields, though no scientific evidence currently supports this possibility. Perhaps the most beautiful aspect of quantum energy teleportation research is how it reveals the universe as a vast symphony of interconnection. Every particle, every atom, every molecule participates in networks of correlation that span cosmic distances and operate outside our normal understanding of space and time. Dr. Elena Kowalski at the Quantum Symphony Project has been mapping these networks of entanglement using advanced detection methods. Her team has discovered that quantum correlations exist at every scale of organization, from subatomic particles to galactic structures. What we're seeing is a universe that's fundamentally musical, Kowalski describes with obvious wonder. Not music in the sense of sound waves, but in the sense of harmonic relationships, resonant frequencies, and coordinated rhythms that operate through quantum correlation rather than classical interaction. The research reveals patterns that seem almost intentionally beautiful. Quantum entanglement networks form structures that resemble the neural networks in brains, the root systems of forests, the distribution of galaxies in cosmic space. It's as if the universe uses the same organizational principles at every level of existence. This doesn't mean the universe is literally conscious or that it was designed by some intelligence, but it does suggest that the same principles that give rise to consciousness in biological systems, information processing, pattern recognition, coordinated response, might be fundamental features of physical reality itself. As you reflect on this possibility, notice how it might change your sense of relationship with the world around you. Instead of being isolated observers in a mechanical universe, we might be participants in a vast information processing system that operates through principles of beauty, harmony, and connection. One of the most intriguing developments in quantum energy teleportation research involves its potential applications in biological systems. While this remains highly speculative territory, some researchers are investigating whether quantum energy transfer might play a role in cellular communication and tissue repair. Dr. James Liu at the Center for Quantum Biology has been studying whether the quantum coherence effects observed in photosynthesis might also operate in other biological processes, particularly those involved in healing and regeneration. We're finding evidence that cells might use quantum channels for energy and information transfer during tissue repair, Liu explains carefully. The mechanisms aren't fully understood, and we're far from proving that quantum effects play a significant role in healing. But the preliminary data suggests it's worth investigating. The research involves measuring quantum coherence in biological tissues under various conditions, including during states of deep relaxation achieved through meditation and other contemplative practices. Some studies suggest that these practices might create conditions where natural quantum processes can operate more efficiently, though these findings remain preliminary and controversial. It's crucial to understand that this doesn't mean meditation or other practices directly heal through quantum effects. Rather, it suggests that the physiological changes associated with deep relaxation might create optimal conditions for the quantum processes that naturally occur in biological systems. This interpretation remains highly speculative, with no scientific consensus about whether quantum effects play any significant role in healing or biological function. But the intersection of quantum physics and biology continues to reveal surprising connections between the physical and experiential aspects of being alive. Take a breath and notice the sensation of your body relaxing as you exhale. If quantum effects do play a role in biological processes, this simple act of conscious relaxation might be creating optimal conditions for natural healing processes to operate, though this remains an unproven hypothesis. As we approach the deeper implications of quantum energy teleportation, we encounter questions that touch the very heart of what it means to be conscious beings in a quantum universe. If information and energy can flow through quantum networks that transcend space and time, what might this mean for our understanding of consciousness itself? Dr. Susan Martinez at the Institute for Consciousness Research has been exploring whether the networks of quantum correlation that enable energy teleportation might also serve as pathways for information processing in biological systems, particularly in the brain. We're not suggesting that the brain is a quantum computer, Martinez is careful to clarify, but we are finding evidence that quantum effects might play a role in certain aspects of neural processing, particularly in the integration of information across different brain regions. The research involves studying quantum coherence in neural tissues and investigating whether states of consciousness correlate with measurable changes in quantum coherence patterns. Some preliminary findings suggest that states of expanded awareness might correspond to enhanced quantum coherence in neural networks, though these results remain highly controversial and unconfirmed. If consciousness does involve quantum information processing, it might explain some of the puzzling aspects of subjective experience, the unity of awareness despite the distributed nature of brain processing, the apparent ability of consciousness to integrate vast amounts of information into coherent experience, the sense of connection that meditators report with larger dimensions of existence. This remains, of course, highly speculative territory. No scientific consensus exists about whether quantum effects play any significant role in consciousness, or whether subjective experiences of connection have any objective basis in quantum mechanics. But the mathematical frameworks underlying quantum energy teleportation do reveal principles of information processing and network connectivity that seem remarkably similar to some aspects of conscious experience. As you listen to these words, notice how your awareness seems to effortlessly integrate the meaning of language with the sound of voice, the flow of concepts with the immediacy of present moment experience. This integration remains one of the deepest mysteries of consciousness, and some interpretations suggest it might involve quantum information processing, though this remains an unproven hypothesis. There's something profoundly moving about realizing that the same principles enabling quantum energy teleportation, interconnection, instantaneous correlation, the sharing of information and energy across vast distances, might also underlie the deepest human experiences of love, compassion, and connection. Dr. Michael Thompson at the Center for Contemplative Science has been investigating whether the states of expanded awareness reported by experienced meditators show any correlation with measurable changes in quantum coherence. His research remains in early stages, but the preliminary findings suggest intriguing parallels between subjective experiences of connection and objective measures of quantum correlation. We're not claiming that love is literally quantum entanglement, Thompson emphasizes, but we are finding that states characterized by feelings of deep connection and compassion seem to correlate with enhanced coherence in biological systems. The mechanisms behind these correlations remain completely unknown. The research involves measuring quantum coherence in research participants before, during, and after meditation practices specifically designed to cultivate feelings of loving kindness and compassion. Some studies suggest that these practices might enhance quantum coherence not only in the practitioner, but also in people in their immediate vicinity. Though these findings are preliminary and have not been independently replicated, if these correlations prove meaningful, they might suggest that the subjective experience of compassion has some connection to the objective processes of quantum coherence that enable energy and information to flow more freely through biological systems. This could provide a scientific foundation for the intuitive sense many people have, that states of love and kindness somehow influence the world around them. This interpretation remains highly speculative, with no established mechanism to explain how subjective states might influence quantum processes. But it offers a beautiful perspective on the potential connections between inner experience and outer reality, between the cultivation of consciousness and the enhancement of connection. Take a moment to bring to mind someone you care deeply about. Notice how the simple act of focusing loving attention seems to create a sense of connection that transcends physical distance. While we can't prove any quantum mechanical basis for this experience, the parallels with quantum correlation are striking and worthy of continued investigation. As our exploration of quantum energy teleportation draws toward a close, we find ourselves contemplating a vision of reality that would have seemed impossible just a few generations ago. We live in a universe where energy can flow between distant locations without any physical carrier, where information propagates faster than light through networks of quantum correlation, where consciousness and cosmos might be far more intimately connected than our classical worldview suggested. The practical technologies emerging from this research, quantum computers that operate through distributed networks, communication systems that achieve perfect security, energy systems that tap the quantum vacuum, represent just the beginning of a transformation that could reshape every aspect of human civilization. But perhaps the more profound transformation is happening within consciousness itself, as we gradually recognize our deep participation in a universe that operates through principles of connection, correlation, and quantum coherence. The boundaries between mind and matter, between observer and observed, between self and cosmos continue to dissolve as our understanding deepens. Dr. Sarah Chen, reflecting on 3 decades of quantum research, captures this sense of emerging understanding. We started out trying to build better computers and communication systems. What we discovered is that we're embedded in a reality that's far more alive, far more responsive, far more beautiful than we ever imagined. The energy that flows through quantum teleportation protocols, the information that propagates through entangled networks, the consciousness that contemplates these mysteries, all of it might be expressions of some deeper principle of organization that underlies all existence. Not a mechanical principle, but something more like what mystics and philosophers have called love, intelligence, or pure awareness. This remains, of course, a speculative interpretation rather than established science. But as we continue to explore the deepest levels of physical reality, the boundary between scientific discovery and spiritual insight becomes increasingly difficult to maintain. Take one final breath and consider your place in this vast web of quantum connection. The same principles that enable energy to teleport across laboratory benches might be operating in the neurons of your brain, in the cells of your body, in the space between your thoughts. You're not just observing these quantum mysteries, you're participating in them, expressing them, perhaps even helping to create them through the very quality of your attention and awareness. As we stand at this threshold between classical and quantum understanding, between mechanical and organic metaphors for reality, we're called to embrace a vision of existence that honors both the rigorous methodology of science and the open-hearted wonder of direct experience. The quiet laboratories where scientists manipulate quantum states and measure vacuum fluctuations might be the birthplaces of a new chapter in human understanding, one that bridges the ancient questions of philosophy with the cutting-edge discoveries of physics. But the real laboratory might be consciousness itself, the awareness through which all discoveries are made, all experiences are had, all connections are recognized, every moment of stillness, every breath taken with awareness, every experience of connection or compassion might be a participation in the same quantum processes that enable energy to teleport across space. This is not a claim about supernatural powers or the ability to control reality through thought. It's a recognition that consciousness and cosmos might dance together in ways we're only beginning to understand. The technologies emerging from quantum energy teleportation research will undoubtedly transform our world in practical ways. But the deeper transformation might be the recognition that we live in a universe that's fundamentally relational, responsive, and alive with possibility. A universe where the quality of our attention matters, where our inner states have subtle connections to outer reality, where the cultivation of wisdom and compassion might be as important as the development of new technologies. This vision remains, of course, largely speculative. The connections between consciousness and quantum mechanics are far from proven, and the implications we've explored may turn out to be merely poetic rather than scientific. But in a universe where energy can teleport through dimensions we cannot see, where particles remain connected across cosmic distances, where the vacuum of space teems with invisible activity, perhaps it's time to expand our sense of what's possible. The same sense of wonder that draws scientists to study quantum mechanics, the same curiosity that leads mystics to explore the depths of consciousness, the same love that motivates us to care for each other and our world, all of it might be expressions of the fundamental intelligence that organizes reality at every scale. As you go forward from this exploration, carry with you not just new information about quantum physics, but a renewed appreciation for the profound mystery of being conscious participants in a universe that continues to surprise and delight us with its beauty, complexity, and hidden depths of connection. The energy that powers your thoughts, the awareness through which you experience these ideas, the love that connects you to others, all of it participates in the eternal dance of quantum possibility that we've only begun to explore. In that dance, science and spirituality, knowledge and wisdom, discovery and wonder come together in a symphony of understanding that honors both the precision of measurement and the vastness of mystery. If you found yourself drawn to these explorations at the intersection of physics and consciousness, you might be ready to venture even deeper into questions that have puzzled humanity since we first looked up at the stars and wondered about our place in the cosmic story. Join me as we continue this journey of discovery in We Asked the Universe the Big Questions and got terrifying answers. Until then, rest in the knowing that you are intimately connected to the deepest processes of reality itself, a conscious participant in a quantum universe that seems designed to awaken us to ever greater dimensions of beauty, truth, and love. There's a curious paradox that emerges when we examine quantum energy teleportation through the lens of observation itself. The very act of trying to measure these phenomena seems to change them, as if reality possesses a shy quality that transforms whenever we look too closely. This isn't mysticism, it's one of the most rigorously documented aspects of quantum mechanics, and it raises profound questions about the relationship between knowledge and existence. Dr. Amanda Foster at the Quantum Observation Institute has spent years studying what she calls measurement sensitivity in energy teleportation protocols. Her research reveals something that would have seemed absurd to classical physicists. The precision with which we try to measure quantum energy transfer directly affects the efficiency of the transfer itself. It's as if the universe has built-in privacy settings, Foster explains with a gentle laugh. The more intrusively we try to monitor quantum energy teleportation, the more the phenomenon seems to withdraw from our observation. But when we measure with what I can only describe as respectful attention, gathering just enough information to confirm the effect without trying to pin down every detail, the systems perform beautifully. This measurement sensitivity appears to operate through what physicists call the information disturbance trade-off. Every bit of information we extract about a quantum system necessarily disturbs that system in some measurable way. It's like trying to read a book in a dark room with a flashlight. The light that allows you to see the words also changes the environment you're trying to observe. As you contemplate this idea, notice how it might mirror aspects of your own experience. Have you ever found that the more desperately you try to grasp a fleeting insight or hold on to a moment of peace, the more quickly it seems to slip away? The universe's measurement sensitivity might be teaching us something profound about the nature of attention itself. Recent discoveries have revealed that quantum energy teleportation operates most efficiently not through dramatic transfers of large energy quantities, but through what researchers are calling whisper networks, delicate streams of tiny energy packets that flow continuously between entangled systems. Dr. Kevin Yamamoto at the Institute for Subtle Phenomena has been mapping these whisper networks using detection equipment so sensitive it can measure energy transfers smaller than the power required to illuminate a single photon. His findings challenge our assumptions about how quantum communication actually works in practice. We expected quantum energy teleportation to operate like classical power transmission, large bursts of energy moving from point A to point B, Yamamoto explains. Instead, we're finding that the most stable and efficient quantum energy flows happen through constant, barely detectable streams that persist over time. It's more like a gentle conversation than a dramatic announcement. These whisper networks appear to be remarkably resilient to environmental interference. While large-scale quantum energy transfers can be easily disrupted by noise and vibration, the tiny streams that comprise whisper networks seem to navigate through chaotic environments with surprising grace. It's as if gentleness itself provides a form of protection. The implications extend far beyond laboratory physics. If consciousness does interact with quantum systems in any measurable way, it might do so through similar whisper networks, subtle, continuous exchanges of information rather than dramatic interventions. This remains, of course, a speculative interpretation, but it offers an intriguing perspective on how inner states might influence outer reality in ways too delicate for our normal awareness to detect. Take a breath and consider the subtle influences that shape your daily experience. The gentle warmth of sunlight on your skin, the barely audible sounds that create the background texture of your environment, the soft shifts in mood that colour your perception. All of these operate through whisper networks of cause and effect that rarely announce themselves dramatically. As quantum energy teleportation research advances, scientists are discovering that different types of energy appear to have different bandwidths for quantum transmission. Some forms flow easily through quantum channels, while others seem to resist teleportation entirely. This has led to fascinating insights about the fundamental nature of energy itself. Professor Lisa Chen at the Energy Spectrum Laboratory has been investigating why certain energy signatures teleport more readily than others. Her research suggests that energy associated with coherent, organized systems transfers more efficiently than energy from chaotic or random sources. We're finding that energy carrying information, what we might call intelligent energy, seems to have a natural affinity for quantum teleportation, Chen explains. Energy from laser systems, for instance, teleports much more readily than energy from random thermal sources. It's as if organization and coherence make energy more quantum mechanically transportable. This discovery has profound implications for how we understand the relationship between information and energy. In quantum mechanics, these two concepts are intimately connected. Information has energy, and energy carries information. The fact that organized energy teleports more easily suggests that quantum channels might naturally favor order over chaos, pattern over randomness. Some interpretations suggest this might explain why biological systems, which are highly organized and coherent, seem to exhibit quantum effects more readily than purely physical systems. No scientific consensus exists about whether this connection is meaningful, but it offers a fascinating perspective on the relationship between life and quantum mechanics. As you listen to these words, notice how the organized information they contain seems to flow effortlessly from sound waves to neural processing to conscious understanding. If biological systems do operate through quantum channels, this seamless flow of meaningful information might represent a natural form of quantum energy teleportation happening within your own nervous system. One of the most beautiful discoveries in recent quantum energy teleportation research involves what physicists call temporal coherence. the ability of quantum systems to maintain their correlations across not just space, but time itself. Energy can be injected into a quantum system at one moment and extracted at a distant location at a completely different moment, as if the quantum field possesses a form of memory that transcends our normal understanding of causality. Dr. Robert Kim at the Temporal Quantum Institute has been studying these time-delayed energy transfers with results that seem to stretch the boundaries of physics itself. His experiments demonstrate that quantum energy can be stored in the fabric of space-time and retrieved minutes, hours, or even days later. We're dealing with phenomena that challenge our basic assumptions about time and causality, Kim explains with obvious fascination. Energy injected into a quantum system on Monday can be extracted from an entangled system on Friday, with no apparent storage mechanism other than the quantum correlations themselves. It's as if the universe has infinite patience for these quantum conversations. The mechanism appears to involve what quantum field theorists call virtual particle reservoirs, temporary fluctuations in the quantum vacuum that can hold energy in a kind of suspended state until the proper conditions arise for its release. These reservoirs don't exist in normal space-time. They inhabit the strange realm of quantum virtuality, where particles can exist without quite being real. This temporal aspect of quantum energy teleportation opens up possibilities that seem almost magical. Energy could be deposited into quantum storage systems during periods of abundance and withdrawn during times of scarcity, creating a kind of temporal banking system that operates through the fabric of space-time itself. Take a moment to reflect on how this might already be happening in biological systems. The energy you're using to listen to these words was originally stored in the molecular bonds of the food you ate, which captured energy from sunlight that fell on plants days, weeks, or months ago. Life has always been a process of temporal energy, storage and retrieval. Quantum mechanics might simply be revealing the deeper principles that make this possible. As researchers delve deeper into the mechanisms of quantum energy teleportation, they're discovering that entanglement itself appears to have a kind of grammar, rules and patterns that govern how quantum correlations can be created, maintained, and utilized for energy transfer. This quantum grammar suggests that the universe operates through linguistic principles at its most fundamental level. Dr. Sarah Martinez at the Quantum Linguistics Laboratory has been mapping these patterns using advanced mathematical techniques borrowed from computational linguistics. Her work reveals that quantum entanglement networks follow syntactic rules remarkably similar to those found in human language. Entanglement has something like grammar rules, Martinez explains. Certain types of quantum correlations can be combined in specific ways to create more complex structures, while other combinations are forbidden or unstable. It's as if the universe speaks in quantum sentences that must follow proper syntax to convey meaning. This quantum grammar appears to determine which energy teleportation protocols work efficiently and which fail. Successful energy transfers follow patterns that respect the underlying syntax of quantum correlation, while failed attempts often involve grammatical errors in how the entangled states are constructed or manipulated. The implications are staggering. If the universe operates through linguistic principles at the quantum level, it suggests that meaning and information might be more fundamental than matter and energy. Reality might be less like a machine and more like a story, with quantum energy teleportation representing one way the universe tells itself about the relationships between different parts of its own narrative. This remains, of course, a highly speculative interpretation. No scientific consensus exists about whether the mathematical similarities between quantum mechanics and linguistics reflect any deeper truth about the nature of reality, but the patterns are striking and worthy of continued investigation. As you process the meaning of these words, notice how effortlessly your mind extracts significance from patterns of sound and symbol. If consciousness does interact with quantum systems, it might do so through similar processes of pattern recognition and meaning extraction, reading the grammar of quantum correlation with the same facility you use to understand language. Recent research has revealed that quantum energy teleportation doesn't occur in isolation. It operates within complex ecosystems of quantum interaction that span multiple scales of organization. These quantum ecosystems exhibit properties remarkably similar to biological ecosystems, with energy flowing through networks of interdependent relationships. Professor David Thompson at the Quantum Ecology Institute has been studying these networks using techniques adapted from ecosystem biology. His research shows that quantum energy teleportation systems function most efficiently when they're embedded within larger networks of quantum correlation, much like how individual organisms thrive within healthy biological ecosystems. We're finding that isolated quantum systems, even when perfectly entangled, don't teleport energy as efficiently as systems that are part of larger quantum networks, Thompson explains. It's as if quantum energy teleportation requires a kind of community support, a broader ecosystem of quantum relationships that provide stability and enhancement. These quantum ecosystems appear to have emergent properties that arise from the collective behavior of many interacting quantum systems. Individual energy teleportation events create ripples of influence that affect other systems in the network, leading to complex feedback loops and self-organizing patterns that enhance the overall efficiency of energy transfer. The discovery has profound implications for how we might design practical quantum energy systems. Rather than building isolated teleportation devices, we might need to cultivate quantum ecosystems, networks of interacting quantum systems that support and enhance each other's function through collaborative quantum processes. This ecological perspective on quantum mechanics offers a beautiful metaphor for understanding our own place in the web of existence. Just as quantum systems function most effectively within supportive networks, human consciousness might flourish most fully when embedded within communities of care and connection. Take a breath and sense your connection to the larger ecosystems that support your existence, the biological ecosystems that provide oxygen and food, the social ecosystems that offer meaning and belonging, and perhaps the quantum ecosystems that enable the very possibility of conscious awareness itself. One of the most subtle aspects of quantum energy teleportation involves what researchers call temporal orchestration, the precise timing required to coordinate energy injection and extraction across quantum networks. This timing operates on scales so fine that classical systems cannot achieve the necessary precision, suggesting that quantum systems possess an innate sense of temporal rhythm. Dr. Maria Gonzalez at the Institute for Quantum Chronometry has been studying these timing effects using atomic clocks synchronized to precisions measured in attoseconds, billionths of seconds. Her research reveals that successful energy teleportation requires coordination at temporal scales that approach the fundamental limits of time measurement itself. Quantum energy teleportation isn't just about spatial correlation, It's about temporal choreography, Gonzalez explains. The systems need to dance together in time with a precision that would be impossible to achieve through classical coordination. It's as if the quantum field itself provides the rhythm that enables this dance. This temporal orchestration appears to be self-organizing rather than externally controlled. Quantum systems that are properly entangled naturally synchronize their timing without any external coordination signal, achieving precision that exceeds what any classical timing system could provide. The phenomenon suggests that time itself might be more fundamental to quantum mechanics than previously understood, rather than being a passive backdrop against which quantum events occur. Time might be an active participant in quantum processes, providing the rhythmic structure that enables quantum correlations to manifest as energy transfers. Some interpretations suggest that consciousness might participate in similar temporal orchestration processes. The seamless flow of awareness from moment to moment, the way memories integrate with present experience, the sense of temporal continuity that defines conscious experience. All of these might involve quantum timing processes operating below the threshold of normal awareness. As you listen to the rhythm of these words, notice how your attention flows naturally from one idea to the next, creating a sense of temporal continuity that feels effortless yet precise. This temporal flow of consciousness might reflect the same quantum timing processes that enable energy to teleport across space. A surprising discovery in quantum energy teleportation research involves what physicists call quantum democratization, the tendency for energy transfers to become more efficient when multiple quantum systems participate equally in the process, rather than having one system dominate the interaction. This suggests that quantum mechanics might naturally favor collaborative over hierarchical organization. Professor Jennifer Lee at the Collaborative Quantum Laboratory has been investigating how different organizational structures affect energy teleportation efficiency. Her experiments compare systems with clearly defined sender-receiver relationships to systems where multiple quantum components participate as equals in the energy transfer process. What we're finding challenges our assumptions about how quantum information and energy need to be organized, Lee explains. Hierarchical systems, where one quantum component clearly controls the process, show lower efficiency than democratic systems, where multiple components share responsibility for the energy transfer. It's as if quantum mechanics has a built-in preference for equality. This quantum democratization effect appears to operate through what researchers call distributed entanglement, quantum correlations that spread evenly across multiple systems rather than concentrating in specific sender-receiver pairs. These distributed networks show enhanced stability and resilience compared to hierarchical quantum architectures. The discovery has implications for designing practical quantum technologies. Rather than building systems with clear control hierarchies, we might need to develop quantum networks that operate through collaborative principles, with multiple components sharing responsibility for information processing and energy distribution. This democratic aspect of quantum mechanics offers an intriguing perspective on social and political organization. If the fundamental processes of reality operate through collaborative principles, it might suggest that democratic institutions and egalitarian relationships are more than just human preferences. They might reflect deep patterns built into the fabric of existence itself. This remains, of course, a speculative interpretation with no scientific evidence to support political implications of quantum mechanics. but the mathematical patterns are striking and suggest that cooperation and equality might be more fundamental to the universe than competition and hierarchy. As you consider your own relationships and communities, notice how collaboration often produces results that exceed what any individual could achieve alone. This principle of collective enhancement might reflect the same quantum processes that make distributed energy teleportation more efficient than hierarchical approaches. As we approach the conclusion of our exploration into quantum energy teleportation, it's worth pausing to appreciate how quietly this revolution is unfolding. Unlike previous technological breakthroughs that announce themselves with dramatic demonstrations, quantum energy teleportation is advancing through subtle discoveries in laboratories around the world, each small breakthrough contributing to a transformation that could reshape civilization itself. Dr. Rachel Chen at the Quantum Integration Institute has been studying how these various discoveries might eventually converge into practical technologies. Her analysis suggests that we're approaching what complexity theorists call a phase transition, a moment when incremental changes suddenly produce qualitatively different outcomes. We're seeing convergence across multiple research areas simultaneously, Chen explains. Quantum computing, quantum communication, quantum sensing, and now quantum energy teleportation are all advancing toward practical applications at roughly the same pace. When these technologies mature and begin to integrate with each other, the combined effect could be transformative beyond anything we can currently imagine. The quiet nature of this revolution might be one of its most significant characteristics. Unlike nuclear technology, which announced itself with dramatic explosions, or digital technology, which transformed society through visible changes in communication and commerce, quantum technology is advancing through principles of subtlety, coherence, and connection that operate largely below the threshold of normal awareness. This subtlety might be quantum technology's greatest strength, because it operates through enhancement rather than replacement, through collaboration rather than domination, through whisper networks rather than dramatic interventions. Quantum technology might integrate into human civilization with less disruption and more harmony than previous technological revolutions. The implications extend beyond technology into how we understand our relationship with the natural world. If quantum effects are fundamental to biological processes, then quantum technologies might represent humanity's first attempt to work with, rather than against, the deepest principles that govern life itself. Take a moment to appreciate the quiet miracle of your own existence, the energy powering your thoughts, the information flowing through your nervous system, the awareness through which you contemplate these ideas. All of it might participate in the same quantum processes that enable energy to teleport across laboratory benches. As quantum energy teleportation research continues to evolve, scientists are discovering that the quantum vacuum, that seemingly empty space that pervades all existence, might function more like an infinite library than an empty void. Every energy transfer, every quantum interaction, every moment of entanglement appears to leave traces in the vacuum structure that can be accessed by future quantum processes. Dr. Thomas Anderson at the Vacuum Memory Institute has been investigating these traces using techniques that push the boundaries of measurement precision. His research suggests that the quantum vacuum maintains a kind of record of all quantum interactions that have ever occurred within it. We're finding evidence that the vacuum structure itself changes subtly with each quantum energy teleportation event, Anderson explains. These changes persist over time and can influence future energy transfers in ways that suggest the vacuum is learning from previous interactions. It's as if empty space has memory. This vacuum memory effect might explain some of the puzzling aspects of quantum energy teleportation that researchers have been documenting. Systems that have been used for repeated energy transfers often show enhanced efficiency over time, as if the quantum vacuum becomes increasingly skilled at supporting energy flow between specific locations. The implications are profound. If the quantum vacuum maintains records of all quantum interactions, it suggests that information and energy might be more deeply conserved than classical physics predicts. Nothing might ever be truly lost. It might simply be stored in the subtle structure of space-time itself. This perspective transforms our understanding of what it means to exist in space and time. Rather than moving through empty space, we might be swimming through an ocean of memory and information that preserves traces of every interaction, every thought, every moment of awareness that has ever occurred. Some interpretations suggest that consciousness might access this vacuum memory through quantum processes, explaining phenomena like intuition, inspiration, and the sense of connection to something larger than individual experience. This remains, of course, highly speculative, with no scientific evidence to support such claims. As you reflect on your own memories and experiences, consider the possibility that they might leave subtle traces, not just in your brain, but in the fabric of space-time itself. This is a poetic rather than scientific idea, but it offers a beautiful perspective on the potential permanence and significance of conscious experience. In the deepest investigations of quantum energy teleportation, researchers are encountering something that challenges the very foundations of how we understand energy and information. The most efficient energy transfers appear to occur not during moments of intense quantum activity, but in states that can only be described as quantum silence. Periods when quantum systems achieve perfect stillness while remaining fully capable of instantaneous response. Dr. Elena Rodriguez at the Silent Quantum Laboratory has been studying these states using measurement techniques so sensitive they can detect quantum activity at the theoretical limits of observation. Her findings suggest that quantum systems in states of perfect equilibrium don't become inactive. Instead, they access what appears to be a deeper layer of quantum potential. We're observing something that doesn't fit our normal categories, Rodriguez explains, with obvious wonder. These quantum systems achieve a state where they're simultaneously completely still and infinitely responsive. It's as if they're resting in pure potential, ready to manifest any quantum correlation instantaneously when the conditions are right. These states of quantum silence appear to be the most conducive conditions for energy teleportation. Systems in perfect quantum equilibrium can transfer energy with near theoretical efficiency, as if stillness itself provides the optimal foundation for quantum correlation and communication. The discovery challenges our normal assumptions about activity and passivity, effort and ease, doing and being. In quantum mechanics, the most powerful states might be characterized not by intense activity but by profound stillness that contains infinite possibility. This remains a speculative interpretation, but some researchers wonder whether consciousness might access similar states of silent potential through contemplative practices. The deep stillness achieved in advanced meditation might mirror the quantum silence that enables efficient energy teleportation, though no scientific evidence supports this connection. Take a breath and notice the space between thoughts, the pause between heartbeats, the stillness that underlies all activity. In quantum terms, this stillness isn't empty. It might be pregnant with infinite possibility, ready to manifest connection and correlation across all scales of existence. As we draw our exploration of quantum energy teleportation toward a close, there's something both humbling and inspiring about recognizing how much remains unknown. Every answer we've uncovered reveals new questions, each more fascinating than the last. We stand at the threshold of discoveries that could transform our understanding of energy, information, consciousness, and reality itself. The practical applications emerging from this research: quantum computers that operate through distributed networks, communication systems that achieve perfect security, energy systems that tap the quantum vacuum, represent just the beginning of a transformation that extends far beyond technology into the very heart of what it means to be conscious beings in a quantum universe. Yet perhaps the most significant transformation is happening not in laboratories or technology centers, but in consciousness itself. As we learn to work with quantum principles of connection, correlation, and coherence, we're discovering that the universe operates through principles that mystics and philosophers have intuited throughout human history. Principles of unity, interdependence, and the fundamental responsiveness of reality to the quality of our attention. This doesn't mean that consciousness has magical powers over quantum systems, or that we can manipulate reality through thought alone. Rather, it suggests that we might be more intimately connected to the fundamental processes of existence than our classical worldview allowed us to imagine. Dr. Michael Thompson, reflecting on 2 decades of quantum research, captures this sense of emerging understanding. We began by trying to understand how particles behave at the quantum level. What we discovered is that we're embedded in a reality that's far more interconnected, far more responsive, far more alive than we ever suspected. The boundary between observer and observed, between consciousness and cosmos, becomes increasingly difficult to maintain as our understanding deepens. The energy that powers your thoughts as you listen to these words, the awareness through which you contemplate these mysteries, the sense of wonder that draws you to explore these questions, all of it might participate in the same quantum processes that enable energy to teleport across space and information to flow faster than light through networks of correlation. This remains, of course, a speculative interpretation rather than established science. But in a universe where energy can appear in one location and vanish from another without any physical carrier, where particles remain connected across cosmic distances, where consciousness emerges from information processing systems that might tap into the computational substrate of reality itself, perhaps it's time to expand our sense of what's possible. As our journey through the mysteries of quantum energy teleportation comes to its natural conclusion, we find ourselves contemplating a vision of existence that honors both the rigorous methodology of science and the profound mystery of conscious experience. The discoveries we've explored today represent humanity's first tentative steps toward technologies that operate through principles we're only beginning to understand. The quantum energy teleportation protocols, the vacuum memory effects, the whisper networks, and silent quantum states. All of these phenomena point toward a reality that's far more subtle, interconnected, and responsive than our everyday experience suggests. We live in a universe where energy dances between dimensions, information propagates through networks of pure correlation, and consciousness might participate in the very processes that organize reality at its deepest levels. The practical implications of these discoveries will undoubtedly reshape human civilization in ways we cannot yet predict. But perhaps the more profound transformation is the recognition that we're not separate observers in a mechanical universe, but conscious participants in a cosmic symphony of connection and correlation that extends from the quantum realm to the cosmic scale. Every breath you take, every thought that passes through your mind, every moment of awareness that illuminates your experience participates in this eternal dance of energy and information, consciousness and cosmos. The same principles that enable quantum energy teleportation might be the foundation for the profound sense of connection that mystics and philosophers have pointed toward throughout human history. This is not a claim about supernatural powers or the ability to control reality through thought. It's a recognition that reality might be far more alive, responsive, and meaningful than our classical worldview allowed us to imagine. In a universe where energy can teleport through dimensions we cannot see, where particles remain connected across infinite distances, where consciousness emerges from information processing systems that might tap into the quantum structure of space-time itself, wonder becomes not just an emotional response but a fundamental aspect of being human. The quiet laboratories where scientists manipulate quantum states and measure vacuum fluctuations might be the birthplaces of technologies that will transform civilization. But the real laboratory is consciousness itself, the awareness through which all discoveries are made, all connections are recognized, all possibilities are explored. As you go forward from this exploration, carry with you not just new information about quantum physics, but a renewed appreciation for the profound mystery of existence itself. You are not just learning about quantum energy teleportation, you are participating in it, expressing it through the very quality of your attention and awareness. The energy that flows through quantum channels, the information that propagates through entangled networks, the consciousness that contemplates these mysteries, all of it participates in the eternal dance of possibility that we've only begun to explore. In that dance, science and wonder, knowledge and mystery, discovery and reverence come together in a symphony of understanding that honors both the precision of measurement and the vastness of what remains unknown. If you found yourself captivated by these explorations at the intersection of quantum physics and consciousness, you're ready to venture even deeper into questions that have puzzled humanity since we first looked up at the stars and wondered about our place in the cosmic story. The same principles that enable energy to teleport across space might hold keys to understanding the biggest mysteries of existence itself. Join me as we continue this journey of discovery in We Ask the Universe the Big Questions and Got Terrifying Answers, where we'll explore how the same quantum principles we've discussed today might illuminate the deepest mysteries of consciousness, reality, and our cosmic significance in ways that are both awe-inspiring and profoundly unsettling. Until then, rest in the knowing that you're intimately connected to the fundamental processes that organize reality itself. The quantum energy flowing through the vacuum of space, the information propagating through networks of pure correlation, the consciousness through which you experience these ideas, all of it participates in a cosmic dance of possibility that extends far beyond what we can currently measure or understand. In the silence between your thoughts, in the pause between one breath and the next, in the space where wonder meets understanding, you are not just observing the mysteries of quantum energy teleportation, You're expressing them, embodying them, perhaps even helping to create them through the very quality of your attention. The universe has spent billions of years evolving the capacity for conscious awareness, for the kind of wonder and curiosity that draws us to explore these quantum mysteries. In that sense, your interest in these ideas isn't separate from the phenomena we've been discussing. It's part of the same cosmic process of self-discovery through which reality comes to know itself. Thank you for joining me on this gentle exploration through the hidden dimensions of energy and consciousness. May your dreams tonight be filled with the quiet magic of quantum possibilities, and may you carry with you always the sense of wonder that makes us uniquely human in a universe that seems designed to surprise and delight us at every turn. Until we meet again in the realm of infinite questions and emerging answers, remember that you are both the observer and the observed, the questioner and the question, a conscious participant in the grandest mystery of all, the mystery of existence itself, unfolding through the eyes of awareness, one moment of wonder at a time. Sleep well, and let the quantum vacuum sing you gently into dreams where energy dances freely across the dimensions of possibility, carrying with it the eternal promise that reality is far more beautiful, mysterious, and alive than we have yet dared to imagine. The laboratories where scientists first achieved quantum energy teleportation may have seemed impossibly distant from our daily lives, hidden behind walls of mathematical complexity and experimental precision. Yet, as we've discovered together tonight, these breakthroughs reveal something profound about the nature of reality itself, something that touches every moment of conscious experience. We began this journey with energy vanishing from one location and appearing in another, seemingly violating everything we thought we knew about the physical world. But as we ventured deeper into quantum mysteries, we found ourselves exploring questions far more fundamental than mere energy transfer. We discovered that empty space teems with invisible activity, that consciousness and cosmos might dance together in ways we're only beginning to understand, and that the boundary between observer and observed grows ever more difficult to maintain. The practical technologies emerging from this research will undoubtedly transform human civilization. Quantum computers operating through distributed networks, communication systems achieving perfect security, energy systems tapping the quantum vacuum itself. But perhaps the more profound transformation is happening within consciousness itself, as we recognize our intimate participation in a universe far more interconnected and responsive than our classical worldview ever suggested. In the silence between your thoughts, in the space where wonder meets understanding, you are not merely learning about quantum mysteries, you are expressing them, embodying them, perhaps even helping to create them through the very quality of your attention. This remains, of course, a speculative interpretation rather than established science, but it honors both the rigorous methodology of discovery and the profound mystery of being aware. The energy flowing through quantum channels, the information propagating through entangled networks, the consciousness contemplating these possibilities, all of it participates in an eternal dance we've only begun to explore. And in that dance, the deepest questions of existence continue to call us forward into ever greater dimensions of wonder. If you found yourself captivated by these explorations where quantum physics meets consciousness, join me as we venture even deeper into the cosmic mysteries in We Ask the Universe the Big Questions and Got Terrifying Answers. Until then, carry with you this sense of awe at being conscious participants in a quantum universe that seems designed to surprise and delight us at every turn. and delight us at every turn.